Hello again, this is Mark Summers from Summers Technical Services. Going to do part two for our waveguide assembly. We're going to build a flange, and so we'll start a new part model like usual, and we'll choose the inch template. And since this part has lots of cylindrical features, it only makes sense to do a revolve feature for the first feature. And we could sketch on either the top plane or the right plane. Either one makes logical sense. And so I'll go sketch. And first thing I'll do is define my centerline rotation axis. And so I'll make me a centerline going right through the top plane and make it infinitely long like I like to do. And since it's still blue, I know it's not really tied to the origin, and so I'll make that coincident constraint, and now I can start doing my revolve sketch. I want my front plane to be on the plane that's the same face as the starting face of the waveguide part, and so this will be my defined as the front plane. So I'll do my sketch, looks something like this. Now I've got my closed loop. First thing I'll do is put my dimensions on here for these diameters, and I'm using the data for the WR34 waveguide per the data sheet that I handed out in class. And so we'll use my smart dimension, and if I'm smart and I dimension to the center line, what happened here? If I dimension to my center line, I can do one of two things. I can do a radius. If I don't click here and I pull down here, it'll display as a diameter, and that's what I want. I'll do the same thing over here. Since I've already selected the center line, it assumes I still want diameters, and so I'll place all these, or I'll put all these diameter dimensions on here, and now I'll go back and look at my WR34 waveguide. This diameter looks to be 1 1/8. This diameter here looks to be 0.625. And this one also looks to be 0.625. Now I can do my thicknesses. Just put in the same dimensions that are on the sketch, or on the data sheet. That's 0.32. The overall is 1/4 of an inch. And the dimension from this face to the front face looks like it's 130. Get all these numbers typed in. And it looks like I've got a fully defined sketch. And I'll get out of the sketch and go to Features, Revolve. It assumes I want to revolve about the only axis I have in my sketch, which is correct. It assumes I want to go 360 degrees. And so there's a nice start to my flange model. Now I'm going to cut a extrude cut through the body so I can get my waveguide through. So I'll sketch on this front face here. It'll let me. And I'll do another center point rectangle. And I'll add my dimensions, the width and the height of my WR34 waveguide, which is, this dimension looks to be 1/4. And this dimension looks to be 42. So now that's done. Now I can do an extrude cut. In my design intent that it always goes all the way through the part, so I'll change that to through all. And now I'm ready for my holes. So I've got 440 counterbore tapped holes. Unfortunately, the hole wizard won't let me do counterbores and tapped holes at the same time. So I want to come in here and do a hole wizard and do the tapped holes first. And I'll select tapped holes. And it's the inch. Tapped holes, 440. Through all. I want my thread call out, I want my thread class, I don't want any of these countersinks. Now I'll go to positions, I want to put them on this face, and I'll just randomly click on these 12, 3, 6, and 9 o'clock positions. Now I've got some tapped holes in here. I'm going to come in here and edit my sketch for my locations. And since these are all on a bolt circle, I'm going to use a construction circle to control these hole locations. So that'll be construction geometries. And I'll make these center points coincident with the construction circle. Coincident. And if I get lazy, I'll just drag these points to the circle that does the same thing. A little quicker. And I lost one of my points for some reason. It's interesting. That point needs to go here. Not sure what happened there. Let's put this point at the origin. And now it's behaving a little bit better. Let's go ahead and put a dimension on this construction circle. And it looks like that diameter bolt circle is 9375. And now maybe I can get back this guy. There's that straight point again. So these all need to line up with the origin. Point there, I want to have to replace. I'm not sure exactly what happened. So let's go add another point over here. And let's make these line up horizontally. This guy, the origin, and this guy need to line up horizontally, and this point and this point in the origin need to line up vertically. So I'm just doing geometric constraints. I don't want to do dimensional constraints unless it's absolutely necessary. So let's go put that back on the origin, make those coincident. Alright, so now I have my 4 points. They're all at the 9, 3, 6, and 12 o'clock positions, and so now my holes should be in the right location. If they don't display like you like, we can turn on annotations and they'll show up like a tapped hole. Right, like I mentioned, the hole wizard doesn't let you do counterbore holes and tapped holes at the same time. So now I'll do a simple sketch, 4 circles, and extrude cut those circles. Rather than relocating these circles, I'm just going to use a current location. If I hover over this existing hole, I get the little black dot in the middle. I can automatically constrain these circles to these existing holes, which is what I want to do. So there's that one. Again, I'm not clicking, I'm hovering over it. I get the black dot, I select it, and it automatically adds that constraint. So here's the last one. Now all I need is some equal constraints. This guy and this guy and this guy and this guy are all equal size. And now I'm through doing geometric constraints. Now I need a dimensional constraint. I just need one of them for the diameter of the counterbore. Now my sketch is fully defined, and I can now exit the sketch and do an extrude cut based on the depth of the counterbore. And now I've got my counterbore holes. Now I need to do my pin press fit holes and the clearance holes. Again, I could use the hole wizard, but the hole wizard is really better for things like tapped holes and counterbore holes. So I'm just going to do a sketch, draw 4 circles, and do an extrude cut. And so let's put some holes over here, or some circles. Put the circles over here. This is my clearance hole, so these I'll make equal. Here are my press fit holes, I'll make those equal. I'll add a construction geometry for a bolt circle. I'll try to be more careful than I was last time so I don't booger it up. And I'm going to push these circles to the bolt circle using my little shortcut. Now I want these to be at 45-degree angles with one another, and I think a good way to do that would be to do some more construction geometry. And so I'll make a line from here to here, right click in chain to stay in the command but be able to draw a separate line. Right click select to get out of the command, turn these into construction geometry, and I'm going to make sure these diagonals actually go through the center point, the origin, and so I'll push those to the origin. And now I've got no geometric or dimensional constraints yet. Everything now is geometrically constrained, and it's exactly like I want, because now these holes live on that circle, and they also live on these diagonals. And so one more geometric constraint might be to make these perpendicular. Now I'm ready for 1, 2 different, or maybe 3 different dimensions. I need this 45-degree angle, but I have no geometry to dimension to, but I really do, because I've got these planes. I don't want to forget about these planes. So I can just dimension to the plane. That takes care of the 45-degree angle. Now I need to define my bolt circle, and I need to define the size of these holes. And that one's 67, and this one is 0615. And I've got a minimum number of minimum number of dimensional constraints. All those values match my data sheet. And so now I can exit the sketch. This is fully defined. Extrude cut. Design intent is to go all the way through. And now I'm done with my flange model. And now we'll build a little pin model, and then we'll be ready to do the assembly model.